Good afternoon, my dear student. Today we will discuss a new subtopic of graph theory, that is formation of incident matrix. So far we have discussed about graph of a network and its associated terminology. For example, node, branch, junction, and we have also discussed about subgraphs of an original graph. The subgraphs, for example, is tree, co-tree, etc. And we know that the branch of a tree is known as twig, and the branch which is not associated with the tree is known as limb. Okay, you know that tree is a subgraph of an original graph which consists of all nodes associated with original graph, and it has no closed loop or closed path, and the branch of a tree is known as twig, and the branch which is not associated with the tree is known as link. Now let me ask you one question: what is the relationship between link and twigs? What is the relationship between links and twigs? Can anyone tell me? You know that twigs is the branch of a tree, and you know that the number of twigs is nothing but the difference between number of nodes and one. That means number of twigs equal to number of node minus 1, n minus 1. And what is the formula to calculate link? I mean, what is the expression of link calculation? You know, link equal to capital L equal to total number of branch B minus total number of node N plus 1. So from this expression we can say that the relation between number of links and twigs is that number of links equal to branch minus twigs. Everyone must remember this point, the relationship between twigs and links. The links is equal to the number of branch minus twigs, the number of twigs, and the number of twigs is equal to the difference between number of nodes and 1, n minus 1, if n is the total number of nodes in a circuit or in a graph. Okay, if you have any doubt regarding the previous subtopic or previous classes discussion, you can write in your chat box. Okay, now I will tell you about incident matrix, and then we will try to understand the steps which are involved to from an incident matrix. What is incident matrix? First question comes in our mind. What is incident matrix? You see that incidence means what? You know, a graph consists of all nodes associated with the circuit and the branches, okay, which actually connect these nodes. We can say that the graph consists of nodes and some connecting branches. Okay, in this context let me tell you the classification of graphs. Okay, classification of graphs are mainly four types. One is connected graph, another one is unconnected graph, third one is directed graph, and final one is undirected graph or unoriented graph. Okay, so therefore graphs are mainly four types: connected graph, unconnected graph, directed graph, and undirected graph. Now let me tell you what is connected graph and what is unconnected graph. Then we will discuss about directed graph and undirected graph. Actually, the directed graph concept or oriented graph concept is required to form an incident matrix. That's why I am discussing about connected graph, unconnected graph, directed graph, and undirected. Connected graph, the name implies that all nodes in the graph are connected with branches. You know that two nodes are connected by a branch. You can say that a node is connected at least one or more than one branches. So such type of graph is known as connected graph. So that means in a connected graph there is no isolated or separated node. All nodes must be connected with branches. There will be no isolated or separated node in a connected graph. If there is a isolated or separated node in a graph, then you can say that corresponding graph is an unconnected graph. Okay. So connected graph means all nodes are connected with the branches. There is no isolated or separated node. On the other hand, an unconnected graph, there is at least one isolated or separated node. Okay. Now tell me what is directed graph and what is undirected graph. Directed graph, for a directed graph, all nodes and branches are numbered. All nodes and branches are numbered, and the arrows are used to to assign the direction of branches. Let me write these things. Directed graph, because this graph is associated with incident matrix. We will calculate or we will form an incident matrix by using a directed graph. Using a directed graph. Directed graph is a graph is said to be directed graph if all nodes and branches are numbered and the branches are assigned by arrows. Okay, by arrows. If branches are not assigned by arrows, then that type of graph is known as undirected graph. Undirected graph. If you have any confusion, any doubt regarding the types of graph: connected graph, unconnected graph, directed graph, undirected graph, you write in your chat box. Okay, about your confusion. About your confusion. Let me write the definition of a directed graph. Okay, definition of a directed graph. What is directed graph? This graph is also known as oriented graph. You just write within bracket oriented graph. That means the direction of the graphs are mentioned. Okay, a graph is said to be directed graph or oriented graph when all the nodes and branches of the graph of the graph are number. That means we have given a number for each and every branch and node. Okay, number. Okay, and the direction directions of the branches. Direction of branches means current direction. Direction of branches mean current direction are assigned. Are assigned. Okay, are assigned. Such type of graph is known as directed graph. A graph is said to be directed graph when all the nodes and branches of the graph are numbered and the direction of the branches are assigned. The direction of branches are assigned by, you just write, are assigned by arrows. By arrows. Okay. Such type of graph is known as directed graph. If the direction of branches or current direction are not assigned by arrows, then that type of graph is known as directed graph. Okay, actually we will try to understand about incident matrix. What is incident matrix? This matrix is actually from by using the concept of directed graph. That's why I have defined here matrix. Okay, incident matrix. What is incident matrix? Incident matrix, you see the node branch is incident to node. Everyone knows that each branch is incident to any one of the node in a graph. Any one node in the graph, any one of the nodes in a graph. Okay, incident. So if we from a matrix in such a way that we can shows the incidence of branches to node. Okay, the incident matrix shows which branches which branch are incident to which nodes. Okay, which branch is incident to which node. Okay, any confusion? Graph theory, coupled circuit and network synthesis will be is in semester. No, graph theory must be included in semester exam. Okay, but couple circuit you a little bit actually we have discussed so far about mutual inductance, self inductance. That thing couple circuit we will not discuss in detail, and synthesis part is not actually uh, synthesis part will not appear in your semester exam. Okay, in your semester exam up to graph theory. I will send you the detailed syllabus for end sem exam and also some suggestive uh, problems for semester exam. Okay, don't worry about that part. Now you try to understand about incident. Yes, Arijit, I will provide the syllabus for end sem exam and also I will provide some sample question for end sem exam. Okay, don't worry about that. But I will set question from graph theory. So that's why everyone try to understand the graph theory clearly. If you have any doubt, any confusion about graph theory topic, you write in your chat box. What is incident matrix? Incident matrix actually a matrix, a matrix, a matrix with a matrix, a matrix with a matrix shows with branch is incident to with node. Okay, so that means we can we can we can draw we can draw the graph by knowing the incident matrix. Okay, and this matrix is applicable for particularly for directed graph, because you see here this matrix shows which branch is incident to which node. That means there must be direction mentioned. There must be direction of the arrows or of the branches are mentioned for this particular graph. So therefore we can draw a graph by knowing the value of element of incident matrix, or vice versa we can from a incident matrix by knowing the graph representation of a circuit. I will discuss these two things separately and help you uh, for clear understanding about the relationship between incident matrix and graph. How do you draw a graph from incident matrix, and how do you from an incident matrix by using the graphical representation of a circuit. Okay, graphical representation of a circuit. So now let me tell you the incident matrix. You know each matrix has some row and some column. So you can say this matrix has an order. It has an order of what? Of number of rows into number of rows by number of columns. Number of rows by number of columns. Now uh, I will tell you the number of rows, what actually represent the number of rows, and number of columns represent what. Number of rows, actually the number of rows represent the number of rows represent 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 the corresponding corresponding uh, corresponding number of nodes, and on the other hand the number of columns represent represent the corresponding number of branches, okay. Column represent the corresponding number of corresponding number of branches. You know, is branches is graph consists of some nodes and some branches. Okay, and for directed graph you know that each branch must be assigned by an arrow. That means in the directed graph, for a directed graph the current direction must be mentioned. Okay, must be mentioned. Okay, now if number of rows equal to number of nodes equal to suppose n, and number of branch equal to m, so therefore order will be n by m. The order will be n by n. If the number of nodes for a graph is capital N and number of branch for a graph, directed graph is capital M, then you can say that the order of the graph is M by N. M by N. Now our next objective is to find out or determine the values of element of the incident matrix. How do we calculate the values of element or entries, okay, of incident matrix? Well, incident matrix nothing but a matrix having order n by m, where n is the number of nodes and m is the number of branch. It shows which branch is incident to which node. Okay, and the values, let me tell you, the elements of an incident matrix incident matrix incident matrix matrix the elements of an incident matrix having values of one of the three three values these values are plus 1, minus 1 and 0. Okay, so the element of an incident matrix having values of one of the three values plus 1, minus 1 and 0. I will tell you how do we calculate the values of elements for an incident matrix. When the incident matrix element of incident matrix value will be 1, when minus 1, and at which case that will be 0. Okay, you see there are two cases. Either the branch is incident to the node or branch is not incident to the node. Okay, first you consider two cases. One is either the branch, for example, branch is incident to a particular node or node or it is not incident, or the branch is incident to a particular node or it is not incident. Case 1, you just write case 1, the branch, you just write here the branch, it's better to understand, the branch is incident to a particular node. Case 2 the branch is not incident. The branch, case 2, the branch is not incident to a particular node, to a particular node, one given node, concerned node. Okay, to a particular node. Okay, if the branch is incident to a particular node, that time two cases arise, two situation arise. Okay, for this case two situation arise. One is situation 1, situation 1 1 branch is oriented, branch if branch enters to node, if branch enters to particular node, the element value is enters. Okay, minus 1. Situation 2, situation 2, the uh, branch leaves from node. Situation 2, situation 2, if branch leaves from the node. We have discussed these things so far when we have covered cards of current law. Current entered to the node or current leaving from the node. So if branch leaves from the node, then the element value or value of element will be, then the element value is plus 1, plus 1. Okay, and case 3, plus 1, and case 3, case 2. For this case, the value of element is, for this case the value of element is 0. The value of element Okay. Hello. Now am I audible? Hello, my dear student. Hello. 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 Okay, now, okay, Arkodeep, thank you everyone. There is some problem. Now you calculate, you determine the incident matrix for this graph. So what we will do first, first step is, first step is you first note down the number of rows and number of columns for this matrix. You know that number of rows is nothing but the corresponding number of nodes for the particular graph, and the number of columns is nothing but the corresponding number of branches. So first you calculate, everyone calculate number of nodes and number of branches for this graph. Okay, our first task is to calculate the number of number of number of nodes. Number of nodes equal to how much, how many? Number of nodes is 4 is given, mentioned. Then you calculate number of branches. How many branches? Number of branches, number of branches equal to 5. Number of branches, therefore the matrix order is 4 by 5. So matrix you can write, suppose incident matrix is A, A. So A must be equal to, A is incident matrix for our case we have considered here. Suppose incident matrix, suppose A is incidence matrix, incident matrix of order 5, 4 of order 4 by 5, 4 by 5. Okay, so therefore how many number of element you will get? 4 into 5, 20 number of element. So number of rows, first you mention number of rows, 1, then, and you mention you must mention the matrix symbol, third bracket, 3 and 4. This is number of nodes. You just here write number of nodes along the this row total row is 4. Now your next task is number of columns. How many number of columns you will get? You write here the number of columns is 1, 2, 3, 4, 5. This actually indicates, you write here number of columns, number of columns. Okay, number of columns is same as number of branches, and number of number of rows is same as number of you write number of rows, number of nodes. So therefore we will get total 20 number of elements. This element you just write here. Suppose this one is A11, this one is A12, this one is A13, A14. Separate it, give a gap, and this element is A15. Then you can write corresponding to A21, A21, A22. Now you calculate the value of this element A23, A24, A25. Then we will calculate the value of A31, A31, A32, A33, A34, A35, and the final one is A41, 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 A42, A43, A44, and final one is A45. Now our objective is to calculate the values of this element. Suppose this is number of columns and this is number of rows. You mention in line. Now we will calculate the values of A11, A2, yes, column 5, branch 5, row 4, nodes 4. Okay, thank you. Now our objective is to calculate the values of this element. Okay, A11, A12, A13, A14, A15 up to A45. And you know that if a branch is incident to a node, then we know that either the value of the element will be 1, plus 1 or minus 1 depending on the direction of the arrow. If it is not incident on the incident to the node, then its value will be 0. Now we will examine which branch is incident to which node. Okay, you help me. Okay, first we will see branch 1. Okay, branch 1. So branch 1 is incident to node 1. Branch 1 is incident to node 1. You see, incident to node 1, that means it is connected to node 1. But you see, this branch 1 actually leaves from the node 1. So therefore A11 will be plus 1. Plus 1. Everyone try to understand this point. You see, branch 1 is incident to node 1, but branch 1 leaves from node 1. Leaves from node 1, that means it will be plus 1. Now we will check the value of A12. The node branch 2. Branch 2 means this. Branch 2 is not incident by branch 1. You see, this is branch 2. This branch is not connected to node 1. Therefore, A12 will be 0. A12 will be 0. So let me write here. Let me write here for your proper understanding. For your proper understanding, you say note. I will tell you only one for a particular node. Then you calculate yourself for a remaining node. Node 1 is note that branch 1 is incident to node 1 and leaves from it. Therefore the value of element value, hence A11 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 is equal to plus 1. A11 A11 equal to A11 equal to A11 equal to 4. A11 equal to plus 1. Everyone write it. A11 equal to uh, plus 1. Next, branch 2 is not incident to node 1. Branch, write in capital letter. Branch 2 is not incident to node 1. Therefore, A, you just write, therefore A 1 2 equal to 0. A1 to equal to 0. Okay, everyone look at the present slide. For network theory, practical one will be the what? For network theory, practical one will be the viva. Okay, Orkodev, I will decide it later. Okay, and then I will inform the seer. Okay. Now everyone see the value of a11 is equal to plus 1 and the value of a12 equal to 0. But why we have chosen these values? Because you see that no branch 1 is incident to branch node 1. Incident means connected. Everyone must be remember that incident means connected. Okay, so branch 1 is connected to node 1, but it leaves from node 1, that's why plus 1. On the other hand, branch 2 is not incident to node 1, is not connected to node 1, it is connected to node 2 and node 3, that's why a12 equal to 0. Similarly, you can write a14 means branch 4 is not connected to a node 1, a13 branch 3 is not connected to node 1 0 0, but branch 5 is connected to node 1 and it leaves from node 1, that means it will be plus 1. So you just write yourself, this will be 0, a14 also 0 and a15 is plus 1, because you see that 5 this branch is incident connected to node 1 and the arrow actually indicate bottom side towards bottom, that means it leaves from the node 1, that's why plus 1. Now you calculate the values of a21 a22 and a23 and you tell me. Everyone calculate the values of a21 a22 a24 and 25 and you write in your chat box. So you see a21, that means branch 1 or branch 2. You see branch 1 is connected to node 2, node 2 a14 এর জায়গায় 0 লিখতে পারা যদি connect না, yes, yes, Divyajyoti, if it is not connected, the branch is not connected to particular node or concerned node, then it will be 0. If it is connected to the node, then it will be either plus 1 and minus 1. If it leaves from the node, then plus 1. If it entered to the node, then minus 1. Okay, Divyajyoti, understood? Understand? Okay, now you see a21 node 2 is branch 1 is connected to node 2, branch 2 branch this is branch actually 1 is connected to node 2 and it enters to node 2, that means a21 will be how much? Minus 1. a21 will be minus 1. Everyone say the branch 1, this is branch, you just write here inside bracket for better understanding, branches, and here you write inside bracket you write uh, notes. Okay, you write notes. Now you tell me, how do you calculate the values of a22 a23 element, a24 element and a25 element, the values of the element for the given for the incident matrix. The element are second rows and second column element. The second rows and second column elements, you tell me. A22, the branch 2 is incident to node 2, but it leaves from node 2, then that means it will be plus 1. Okay, plus 1. Then you tell me the value of element a23, second row and third column element values. Second row and third column element value, you tell me what will be the value? Plus 1. Yes, sweetie, you are right. Plus 1. Then you calculate the value of element second row second column element a22. A22, A22 plus 1. Now A23, two two branch node 2 is not connected to branch 3. Node 2 is not connected to branch 3. That means it will be equal to 0. 0. It will be equal to 0. And A244 is not, 4 is connected to branch 2. So that means it will be and leaves from branch 2, it will be plus 1. It will be plus 1. It will be plus 1. And A25, 5 branch 5 is not connected to node 2, so it will be 0. It will be 0. Okay, any doubt? To calculate the values of the elements of of A21, A22, A23, A24, A25. 25 is 0, right? Now you calculate yourself the values of remaining elements. Now you calculate yourself the values of remaining element and you write the values of remaining element in your chat box. For example, third row, second column element A31, A32, A33, A34, A35. Then you calculate A41, A42, A43, A44, A45. So now let me write it here. You see A3, the branch 1 is not connected to 3. So therefore it will be 0. Is not connected. 3, 2, branch 2 is connected to 3 and enter. That means it will be minus 1. Minus 1. And 3, row 3 and branch 3 is connected, okay, and leaves. That means it will be plus 1. Plus 1. And A34, node 3, 3 is not connected to 4, 0. 0. And 3, 5, 5 is not connected to node 3, that means it will be 0. Now let us check the values of A41. Okay, the fourth row and first column element. You say no, branch 1 is not connected to node 4, that's why it will be equal to 0. Then you check branch 2. Branch 2 is not connected to node 4, it will be also 0. Then you check node 4 and 3. Branch 3 is connected to node 4 and enters. Okay, A43, 43, 43 enter means it will be minus 1. Leaves plus 1, minus 1. A44, A4 is connected to node 4 and enters. So that means it will be also minus 1. And the final one is A45. 4 is also connected to 5, branch 5 and towards. Okay, it will be minus 1. Okay, now everyone tell me, is it correct or wrong? If you have any doubt, you write in your chat box. A32 minus 1, A41, A41 minus 1. How? A41 is, A44 is minus 1. A44 is minus 1, right? A45 is minus 1, right? Right. Now you see that the sum of values of element for each column, the sum of values of element for each column is equal to 0. If you sum up the values of element for individual column, then you see it will be equal to 0. It will be equal to 0. Okay, so this is one property. This is one property of incident matrix. So the property of incident matrix, you note down that The sum of values of element for individual column of an incident matrix is equal to 0. Is equal to 0. Let me write the properties of an incident matrix. Okay. Properties of properties of incidence matrix. Okay. Properties 1 is that the sum of elements for each column is equal to 0. And the property 2, the determinant of incident matrix of a closed loop is 0. The determinant, you can verify yourself. The determinant of the incidence matrix of a closed path or loop closed loop is 0. Sorry. The determinant of the incident matrix of a closed path or closed loop is 0. You can calculate it for yourself. If you consider the if you consider a particular closed loop, and you consider the individual nodes and branches for that particular closed loop, and you calculate the determinant, you will get 0. Let me tell you by taking an example, taking a closed loop example. Okay, you see there are two closed loop, 1 2 4 1, and another one is 2 3 4 2. These two closed loop. Okay, or you can consider 1 2 3 4 1. So now we will consider this one, 1 2 4 1. Okay, 1 2 4 1. Everyone consider the closed loop 1 2 4 1, and you write the matrix. Okay, you write the matrix corresponding to this closed loop. You write the matrix corresponding to this closed loop and calculate the determinant of that particular closed loop. Then you will get 0. For this closed loop, you will have node 1 2 3 4, total 3 node, and branch 1 4 5. 3 by 3 matrix you will get. 3 by 3 matrix you will get. Okay, 3 by 3 matrix you will get. uh, if you consider a closed loop, consider to verify the property 2 for incident matrix. Consider the consider the closed loop 1 2 4 1, this path 1 2 4 1. Okay, and you write the matrix from the matrix from. If I write closed loop matrix like that, M for example, you number of rows will be 1 1 2 1 2 4. Number of rows mean number of nodes, and number of columns will be branch 1. Just write here branch 1, then branch 4, then branch 5. Okay, now you calculate the values of a11 a A14. He already knows is A15. You just put the values of this element. A21, A24, A25. Now you write the A41, A44 and A45. Okay. Now everyone write the values of this element whatever you got in previous problem. Okay. You just write this value. A11 is plus 1. A11 is plus 1. Okay. Plus 1. A14. A14 is 0. A14 is 0. A14 is 0. And A15 is plus 1. A15 is plus 1. Okay. Then you write the values of remaining element. A21, A25, A2. I have written 4. This will be 4. A24 and A25. So A21 value is minus 1. A21 values is minus 1. A24 values is plus 1. A24 values is plus 1 and A25 values is 0. Okay, zeros 0. Then you write A41. The values of A41 values is 0. A41 values is 0. 0. A44 values is minus 1 and A45 values is minus 1. Okay, A45 values is minus 1. Now you calculate the determinant of this matrix. Okay, 0 0 0 plus 1 minus 1 plus 1 0 plus 1 0 0 minus 1 plus 1 0 0 0 0 minus 1 minus 1 minus. Okay, now you calculate the value of this determinant. Then you can verify the second property of the incident matrix. You know, second property of the incident matrix is that the determinant of incident matrix for a closed loop is equal to 0. So if you calculate determinant of this matrix, then you will get 0. Obviously you will get 0. You know that determinant equal to, for this matrix, the determinant of m equal to uh, equal to this symbol, equal to what, equal to, you can write the first value 1 into this multiplied this one cross 1 minus 1 and this is 0. Then you write plus this case 0. Then you write plus 1 and within bracket you write this is cancel out, this is cancel out, minus 1 plus 1, you write here plus 1 and then 0. So ultimate you will get how much value? You will get minus 1 plus 1. So it will be equal to 0. Minus 1 plus 1, that will be equal to 0. Okay, this is the justification of second property. Okay, the second property of incident matrix is verified. The second property of incidence matrix is verified. Okay, or true? Any doubt? Therefore you can uh, determine the incident matrix for a graph of a particular circuit, or if I give the incident matrix, then you can draw the graph by knowing the number of nodes, branches and their connecting values, element values. Okay. If you have any difficulties to understand, if you face any difficulty to understand this concept, you write in your chat box about your confusion. Okay. Okay. In next class, okay, next Thursday, group A already completed experiment number 8. Group B already completed experiment number 8. So that's why Monday class actually I had a problem. That's why I did not complete the Monday class. So I have planned to take the Monday class on Thursday lab time. Okay, and I already informed Sir about this thing. So I will take a theory class on Thursday at lab time. Okay, and Friday group A will complete experiment number 8 because this lab actually they did not complete experiment number 8 group B. So they must complete experiment number 8 on Friday. Okay, thank you everyone. Let me stop today's lecture here.